Hello, and welcome back to the second podcast on redefining manufacturing excellence. If you have not yet seen my previous podcast, I strongly recommend you do that before you watch this to make some sense of what I'm going to say in the next 10 minutes or so. In the previous podcast, I touched upon redefining some redundant concepts of TPM, lean management, and Six Sigma with the advent of digitization and automation. I will elaborate a little more on that in today's episode. So let us understand a little about how digitization, automation, and upskilling are reshaping the workforce, particularly with a focus on Gen Z, and how we can address the growing labor shortages in developed countries. We will also talk about what I meant by TPM, lean management, and Six Sigma getting redundant. We all know that TPM or total productive maintenance originated in Japan. And what's interesting is how Japan has maintained its leadership in manufacturing excellence that continues to evolve with times. Japan's continued emphasis on quality and productivity has naturally led to the integration of advanced robotics, making it home to some of the world's most sophisticated robotic plants. These plants are prime example of how automation can take over repetitive and hazardous tasks while ensuring consistent product quality. Countries like Japan, where the concepts of TPM have evolved and later been adopted by the West, have now integrated robotics into their manufacturing at an advanced level. Robotics can enhance TPM in ways we couldn't have imagined before. For example, robots can take on maintenance tasks that are either too dangerous or too intricate for human workers. But beyond just the mechanics of it, Japan's approach highlights something more profound: the importance of blending technology with their cultural values of continuous improvement, what is commonly known as Kaizen in the rest of the world and also in Japan. In my view, the evolution of TPM, lean management, and Six Sigma to incorporate modern technologies like digital analytics, automation, and AI isn't just a nice to have, it's essential. The traditional methodologies still hold valuable principles, but they're limited to today's hyper digitalized environment. Let me explain how these technologies are transforming manufacturing with machine learning, digital analytics, advancements. Industries can now collect real-time data from machines and processes. Because of this, companies now use predictive maintenance with sensors and program logic controls instead of relying on periodic maintenance or time-based maintenance, which can lead to unnecessary downtime and additional spare part cost. By analyzing data in real time, they can predict when equipment will fail and fix it before it happens. This reduces downtime, extends machine life, and improves overall efficiency. In the traditional TPM approach, maintenance was often more reactive or based on set schedules, but now, thanks to the digital tools, maintenance is smarter, faster, and more efficient. Even changeovers can now happen at the push of a button. Digital analytics and automation can enable us to inspect even high-speed equipment and product quality with extreme precision. These technologies now help us spot defects or even perform repairs that require high accuracy. These are tasks where human intervention might introduce errors or safety risks. We can even use the supplier data of material quality to ensure the material doesn't need any more quality inspection and that the lines in a smart factory can adapt to the variations in the quality of the material through AI. Using advanced technological concepts, operators' roles are more meaningful. Instead of manually identifying defects or performing repetitive tasks, which adds work for them in addition to operating the lines, their focus moves to monitoring the process and optimizing system. Lean management and Six Sigma, which traditionally involved hands-on problem-solving tools like focused improvement, 7 steps, quality improvement, 10 steps, or traditional Kaizens, YY analysis, Pareto, Fishbone, FMEC, etc. Now, these operators benefit using the data and technology to find deeper insights and drive more impactful improvements. We must first acknowledge that shop floor colleagues must handle much more than just operating the lines in traditional TPM environment. They are often burdened with repetitive tasks like defect detection and fixing, updating PDCA boards, conducting time-based maintenance, online quality checks, executing cleaning, inspection, and lubrication tasks, and so much more. And then recording all of that data into manual pages using Excel sheets or a computer. Remember, digitization doesn't mean you migrate from a piece of paper now to a laptop or a computer and take prints to display them on the board. Operators feel they have to operate the line and do these additional tasks. In traditional TPM, operators have to visually inspect the equipment, creating routing, cleaning defects, and often fix them manually. This was time consuming, and there was always the risk of human error. And because of this, operators are often overstressed with so much work and accountability that they simply switch jobs to non manufacturing. Digital analytics, machine learning, digitization, and automation have addressed many of these issues. Processes are more streamlined, manual work is reduced, and shop floor operators can now focus more on value-added activities. These technologies continuously monitor equipment performance and quality in real time. They can identify defects automatically and even predict failures before they happen. In the traditional approach, maintenance is based on a schedule, meaning machines are maintained even when they don't need it. Or worse, machines are left without any maintenance until they fail unexpectedly. Now, with the advent of smart factory concepts and modern technology, all that happens with an alert signal for what might come next and where the operators sitting in the control room need to go and pay attention. This shift from time-based maintenance to predictive maintenance and condition-based monitoring reduces the burden on operators and is more efficient. The other irritant is updating those PDCA boards. This is such a manual process in many companies even today. Operators must log data, analyze the results, and physically update the boards. This consumes so much of their time in addition to being able to operate the lines, where due to a high number of stops and continuous quality checks, they need more time to execute this flawlessly. In addition, there is material variability. Digital dashboards and real-time data analytics capture and update performance metrics automatically. Only alerts come onto your dashboard panel online or even on your smartphone. And the trigger is only the task that you're expected to execute or have missed to execute. Everything is based on tasks that must be completed, making the process far more efficient. Of course, in all of this, constant upskilling is needed to meet these challenges. There must be innovative ways to continuously train people while on the job. Now, traditionally, operators had to leave the shop floor to attend classroom-based trainings, and lines would have to stop for the duration. But technology has completely changed this. Digital training platforms like augmented reality and virtual reality have transformed how operators learn without ever halting production. There are online training modules that allow operators to learn at their own pace, minimizing disruption onto their day-to-day operations. Special emphasis is given even to work process simplifications, where in the past operators had to juggle running the lines with additional tasks like data entry and system updates. The data entry would be added touch and repetitive with additional copying and pasting into different Excel sheets and several meeting documents. This increases their workload and often leads to inefficiencies or added manpower to execute these tasks. Even in this area, work process automation, what we call RPA or robotic work process automation, has significantly reduced the manual workload and the job. Another major shift that has happened in the way data is handled is in traditional TPM, data collection and trend analysis are done manually. This is time consuming and prone to errors. Operators often worked with historical data, which didn't give them the needed real-time insights. Now, multitasking has become more common, and one individual is asked to manage the maintenance and operations of the equipment with digital and automated solutions. This also changes the dynamics of the entire equipment ownership, where it is not necessary that you operate the equipment you own. Your teammates can share real-time data and updates seamlessly, regardless of the location. This also reduces the time spent in meetings and accelerates problem solving and decision making. We all know that manufacturing has traditionally been seen as labor intensive with many repetitive tasks and manual processes. Take TPM, lean management, and Six Sigma, while they have served as pillars of efficiency for decades, they were often accompanied by a significant amount of manual effort. Operators had to inspect machines, identify defects, update boards, and perform maintenance while keeping production lines running. But now the world is changing. Technology is pushing us forward, and with that comes a critical question. Will this transformation make manufacturing attractive to Gen Z? And can it help solve the labor shortages in developed countries? Generation Z grew up immersed in technology. They're so digitally savvy that they expect any job to involve modern technology. If manufacturing is to appeal to this generation, traditional manufacturing industries need to move towards cutting edge technology and not look into conventional approaches to operate and maintain. That means embracing automation, robotics, artificial intelligence, and data analytics. All things that can transform the image of manufacturing from old fashioned and laborious ways to innovative and forward thinking. In the developing world, people counter argue that they cannot afford and the payback is not there. This is a separate topic for discussion, as I do have examples of state of the art factories, even in the developing world, where they've explored affordable solutions. Gen Z cares deeply about purpose. They want to work in industries that positively impact society and the environment. So, manufacturing plants that invest in sustainable practices and use digital tools to reduce waste and emissions will find themselves much more attractive to this generation. And of course, they are looking for flexibility and growth opportunities. Industries like P&G that invest in continuous learning and upskilling programs primarily use technologies like virtual reality or augmented reality for on the job training so that Gen Z can learn using digital technology and upskill themselves. This also leads to less attrition. We must keep the current workforce as we progress with digitization and automation. Many traditional roles are shifting from purely manual to more digitized and automated. The concept of a smart factory and the factory of the future is not just about running machines, but managing data, troubleshooting using high speed cameras, and optimizing workflows. So, yes, industries need to spend more time upskilling their employees. This is about more than just the state of the art technology and product innovation. It is about thriving in a digital first world. Upskilling empowers employees to handle more complex tasks, like interpreting data from AI driven systems or overseeing predictive maintenance models that focus on tasks to be done and give you real time information with alerts. These intelligent factories ensure that operators are central to the core operations, even as automation takes over the repetitive tasks. This conversation has another dimension. Many developed countries face severe labor shortages, especially in manufacturing related industries. Populations are aging, and fewer young people are entering the workforce. This is where automation and robotics can fill some of the gaps. Robots can take on repetitive, dangerous tasks or those that require extreme precision, allowing companies to do more with fewer employees. At the same time, companies must adopt more flexible work models. Gen Z wants something other than traditional shift job or 9 to 5 job on the shop floor. Gen Z is looking for a lot of flexibility versus the idea that lines will only operate with their physical presence. And the integration of digital technologies including automation, can provide that. For example, remote monitoring of systems from a central room or even from home, hybrid work setups where fewer people are on the floor operating versus people looking at the analytics somewhere centrally are a few examples that can make manufacturing jobs more attractive to the younger generation. Ultimately, the future of manufacturing lies in digital transformation and affordable automation. Intelligent factories must use tools like digital twins, predictive analytics, and machine learning to improve efficiency. Digitization and automation aren't just buzzwords, they are the foundation of the next industrial revolution. And the companies that get ahead now, focusing on technology and upskilling their workforce, will be the ones that attract the brightest talent, including Gen Z. By creating constant environments where workers constantly learn, feel valued, and are part of an innovative industry, will attract the younger generation and solve the labor shortage problem. As the world continues to change, it's crucial that manufacturing evolves along with it. Frankly, there is a lot more to this. In my next episode, I'll be going into specifics of how you should manage each of the phases of progression. I'm often asked how to progress from phase 0 to phase 4 or phase 5 when we face numerous challenges like constant innovation of products and expansion. Additionally, there are attrition issues and the continuous addition of new people in a growing business. So these are all issues. Stable sites with no innovation or expansion often pass the phases much faster. How about the sites that are being constantly challenged with expansion, product, and design innovation, and people turnover? So stay tuned for the next episode. And thanks for watching this one.